All right, good morning, geometry. So today we're doing the last page of the week 11 notes. And the last page is about geometric mean theorems. And geometric mean theorems are going to be important in this upcoming chapter. And this upcoming chapter is right triangle trigonometry. So these are kind of like the end of the similar triangles and the beginning of right triangle trigonometry. It's sort of like uses both concepts in one. So let's see, let's look at my geometric mean theorems. Let me use a different color here. Ooh. All right. Sorry, just getting things sorted out. Okay, geometric mean theorems. So it says given a right triangle with an altitude drawn from the hypotenuse, three similar triangles are created. So here is our right triangle. And remember, an altitude means it is going to form a right angle and go through one of the points. That's pretty much all it means. So it looks like the C got cut off, but that should be triangle ABC. And we have this altitude DC drawn in. And we know it's an altitude because it forms a right angle and it goes to that point C. And it specifically has to be an altitude from the hypotenuse. And the hypotenuse of ABC is AB because it is across from the right angle of that triangle. So, as the theorem stated, three similar triangles are going to be created here when I draw that altitude. So I have my original triangle ABC. They just turned it in this image here. And then I have the smaller triangle. So I have the smaller one here, which is ADC. I guess I should ACD. I should say ACD. And then I have the smallest triangle, which is CBD. And all three of these triangles are going to be similar triangles. So one way to solve problems like this is just split it up into three smaller triangles and see what you're working with, see what you can, what statements you can make about similarity, and then solve perhaps. So it also has some of our possible proportions set up here. So it says BD over CD, so there's BD and CD on that triangle, equals CD over AD. So CD over AD. So they said the short side of this triangle divided by the long side of this triangle equals the short side of this triangle divided by the long side of this triangle, which is true because they're similar triangles. And we'll notice that when we do our cross multiplication, we have CD times CD. We'll notice the exact same thing with all three of these. And the thing that you're multiplying by itself is what is called the geometric mean. So that's why these are called geometric mean theorems. So that is our geometric mean. And let's look at our other proportions. So it says AB over CB. So they're saying AB over CB, which is the hypotenuse over the short side, equals CB over DB. So that is the hypotenuse over the short side of our smallest triangle. And if we look at the actual diagram, we can see where those fall in. So let's see. Yeah, those would all be on the actual triangle. So they would be saying that like this, wait, AB over CB, just taking a second. So AB over CB is proportional to CB over DB. So we can see how our proportion uses that side CB twice. And our final statement was AB over AC. So that uses this triangle here. So AB over AC is proportional to AC over AD. So the hypotenuse over the long side is proportional to the hypotenuse over the long side. And really, we just need to think about that altitude, splitting it up into 3 smaller similar triangles. Well, 2 of them are smaller, one of them is still the same triangle that we started with. So let's see some examples of this. When the altitude is drawn to the hypotenuse of a right triangle, the length of the altitude is the geometric mean between the segments of the hypotenuse. So that's saying that when I draw in this altitude to the hypotenuse, so I have my big triangle ABC, and this altitude, CD, was drawn in. And it's saying that the length of the altitude is going to be the geometric mean. So remember, the geometric mean is that number there. That's going to be multiplied by itself when I do my butterfly method. And we can see the proportions they set up here. So if we pay attention to like just the smaller triangle here, they have AD over CD, so that's the short leg over the long leg, is proportional to CD over BD. So those are both in my larger triangle. Or I guess I should say like the medium triangle, because it's not the largest triangle. The largest triangle is the entire thing. And it said CD over BD, so that's the short leg over the long leg, just like with AD over CD. So they did short leg over long leg and set that up as their proportion. So let's do it here. I'll do the exact same thing. I have on my smaller, or my medium triangle, I guess, I have that the long leg is 9, the short leg is x. So on this one, I'll do long leg over short leg. This is going to equal, and then I have to do long leg over short leg on the next one too. And I can't look at the entire triangle. I can't look at this whole thing because I don't know the measure of the long leg or the short leg on that. But on the smallest triangle, I do know the measure of the long leg and the short leg on that. So the long leg is x, and the short leg there was 3. So to solve for x, I'm going to do my butterfly method, my cross multiplication. 9 times 3 is 27, and x times x is x squared. And to solve for x now, I just want to take the square root of both sides. So the square root of 27 equals x. And I want to simplify this square root if I can, and that's what we just did on Friday. So let's see, if I have the square root of 27, 27 can split up into the square root of 9 times the square root of 3. And that square root of 9 is going to become 3, and that square root of 3 just stays like that. So there's my answer for x. X is 3 square roots of 3. All right, our other geometric mean theorem says that when the altitude is drawn to the hypotenuse of a right triangle, each leg is the geometric mean between the hypotenuse and the segment of the hypotenuse adjacent to that leg. So let's see what that means. So we have an example here. We have x over leg 1. So those are both in this small triangle there. It is like the short leg basically over the hypotenuse, because leg 1 is, in this case, the hypotenuse of that small triangle, equals leg 1 over AB. So equals, once again, the short leg over the hypotenuse. So the short leg is leg 1, and AB is the hypotenuse of the big triangle. And likewise, we have this proportion, y over leg 2. So let's see. If I'm looking at this medium triangle here, I have y as my long leg, this medium triangle. Y is my long leg, and leg 2 is the hypotenuse of that. And if I'm looking at the entire triangle, I have leg 2 over AB, so that would be the long leg over the hypotenuse. So there are several proportions we could set up. We just need to be able to figure out which ones we are actually able to set up using what's given. So this example here, I have a 9 there, I have a 3 there, and I have a y there. So let's see. I need to figure out which of my 3 triangles I'm going to be using here. So if I'm looking at this smaller triangle, I have a hypotenuse and I have a short leg. Okay, I can work with that. There's 2 measures there that I'm able to use. If I'm looking at my medium triangle here, I have the long leg, but there is no measure on the hypotenuse, and there is no measure on the short leg, so I'm not really able to say anything about that. But if I look at the entire triangle, so, the entire triangle, I have a short leg, which is that y. I don't have a long leg. Don't know what the measure of that is. But my hypotenuse there is the 9 and the 3. So I have to do 9 plus 3, which is 12. So I will do that. That entire length there is 12. So let's see. Going back to the beginning, I said that on my small triangle, the hypotenuse was y, the short leg was 3. So I'll do hypotenuse over short leg. So y over 3 equals, and then on my biggest triangle, the hypotenuse was this 12, and the short leg was y. And even though I have the y in different positions here, because earlier it was we had that geometric mean in the bottom on the first fraction and the top on the second fraction, it doesn't matter, it is still our geometric mean because it's going to be multiplied by itself. So I'm going to do my cross multiplication. Y times y is y squared. 12 times 3 is 36. Take the square root of both sides. Y equals 6. Okay. Continuing on. So let's see. On this example here, I am looking at my small triangle, which has a short leg and a long leg on it. The short leg is 4, the long leg is x. And my medium triangle, which also has a short leg and a long leg. The short leg is the x, the long leg is 25. So short leg over long leg, so 4 over x equals short leg of the medium triangle over the long leg of the median triangle, 25. I'm going to do my cross multiplication here. So let's see. I have 4 times 25 is 100. x times x is x squared. Take the square root of both sides. Hopefully we know that the square root of 100 is 10. So x equals 10 on this problem. Okay, and our final problem here. All right. So on this one, I'm looking at well, we have two variables here. I'll solve for x first. So looking at this, I guess, medium triangle here, I have the hypotenuse, which is the x, and I have the long leg, which is 20. And if I look at the large triangle, the biggest triangle, I have the hypotenuse, which is 20 plus 15, is not just 20. So I have 20 plus 15, which is 35, and I have the long leg, which is x. So I said that x was the hypotenuse of the medium triangle, and 20 was the long leg. And on my big triangle, the hypotenuse was 35, and the long leg was x. So hypotenuse over long leg and hypotenuse over long leg. So I'm going to do my butterfly method. So I have x times x is x squared. 20 times 35 is 700. If I take the square root of both sides, that'll help me solve for x. So x is going to equal the square root of 700. I'm going to split that up into the square root of 100 times the square root of 7. The square root of 100 turns into 10. The square root of 7 doesn't simplify. So x equals 10 square roots of 7. And now I need to solve for y. So I said x equals 10 square roots of 7. And to solve for y, I'm going to do basically the same thing. So now, to solve for y, I'm looking at my little triangle, which has the short leg is 15, and the hypotenuse is y. By the way, remember that the way I'm identifying the hypotenuse is by saying it's the one across from the right angle of that right triangle, because these are all going to be right triangles for today. So I have the short leg over the hypotenuse, so that'll probably give me a proportion. I'll just say short leg over hypotenuse, 15 over y. And then, let's see, if I look at my entire triangle, I have the short leg is going to be the y, and the hypotenuse is going to be the 20 plus the 15 again, just like in the last problem. The 20 plus 15 is 35. I'm going to do my butterfly method. 15 times 35 is 525. And y times y is y squared. Take the square root of both sides to solve for y. And let's see, this is going to split up into the square root of 25 times the square root of 21. It's just going to equal, nope, not even y squared, just y, because the square root of y squared is just y. The square root of 25 is 5. The square root of 21 can't be simplified. So y is going to equal 5 square roots of 21. And that would be the end of the week 11 notes. And now you can finally submit those. So let's look at today's assignment. Just because there are a couple problems I want to go over, or at least set up first. So let's see, this is today's assignment. So you guys can pause the video and pull it up in Schoology. And there are 18 problems on it, and I believe I want to go over 6 of them. So, you know, I'm not going to walk you the entire way through them, but I will help you get them set up. So if I'm looking at number 1 here, I just need to identify what parts of which triangles I'm given. So if I look at my smallest triangle, so I have the short leg is 36, the long leg is x. So short leg over long leg is what I'm given there. If I look at the big triangle, so if I look at the largest triangle I'm given, I do not know either of the legs of that triangle, but I do know the hypotenuse. So that's only one thing, so I can't be using the big triangle here. But if I look at the medium triangle, so this one here, I have my short leg is x, but I don't know the long leg. I don't know the hypotenuse either. But I can figure out the long leg, because remember, our last one, or when we did the, we identified the measures of the smaller triangle, we said it was the short leg, which was 36, over the long leg, which was x. And here we have the short leg is x, and if this entire side is 100, and this part is 36, then this part is 100 minus 36. So 100 minus 36 is going to give me 64. So our long leg of the medium triangle is 64. So please identify which parts of which triangles you're given. And this is the proportion you'd set up, and you guys would solve that on your own. You will also have to do the same thing for number 3. Let's see. On number 7, so this one, we've seen some problems like this in the notes. I have my small triangle, the short leg of which is x, the long leg is 12. So x over 12 is going to equal my medium triangle, which the short leg of which is 12, the long leg is 16. So I do my cross multiplication. So x times 16 is 16x. 12 times 12 is 144. Divide both sides by 16. And x is going to equal 9. So that one, I did the entire thing for you. But I was just doing that one because, all the examples we saw, we had to take a square root of something, but on this one we didn't, because on this one, instead of x being the geometric mean, the 12 was our geometric mean. And it's going to be like that for number 8 as well, and probably some others, I'm not sure. Yeah, for number 9 it'll be the same, for number 10 it'll be the same, for number 11. Yeah, okay. So next problem I want to do together, or set up together, will be number 13. So on number 13, looking at what measures I'm given, on the small triangle, I'm given the short leg and the hypotenuse. So the short leg, we'll do short leg over hypotenuse, 36 over 60. And on the big triangle, like the entire triangle, not the medium one, the big one, my short leg is going to be 60, and my hypotenuse is going to be this entire side. So x plus 36. And I know you guys know how to solve that proportion, so you would solve this proportion for x. And you would do the same thing for 15. 15 is going to be similar to that one. For number 14 here, I want to go over this one as well. So let's see. I have my medium triangle, which has a short leg and a long leg on it. It has that 48 and that 64. But then if I look at the small triangle, I'm not given anything except for the 48. If I look at the biggest triangle, I'm only given the hypotenuse. So on this one, the or this length right here, if the entire length right here is x, and this part is 64, then this is x minus 64. So that's how we would set it up. We said the short leg of the medium triangle was 48. The long leg was 64. The short leg of the smaller triangle was x minus 64. The long leg of the smaller triangle was 48. And that's how you would set that up and then solve it. I know you guys know how to solve for x on that one as well. Okay, number 17. Let's see. So looking at my small triangle here, I have the short leg and the long leg. And looking at the big triangle, I have the short leg and the long leg, or not the big triangle, the medium triangle. So I can do short leg over long leg. So 8 over w plus 9 equals w plus 9 over 18. Short leg over long leg, short leg over long leg. So when I do my cross multiplication, I am going to have 8 times 18, which is 144, equals w plus 9 squared. I know that we know how to multiply that out and write it into a polynomial because that's part of the Algebra 1 curriculum. So if you're taking this class, you have done that. You know how to multiply w plus 9 times w plus 9. But we don't want to do that here. That's just going to make it harder on ourselves. Instead, from this step, I just want to take the square roots of both sides. So the square root of 144 is 12, and then w plus 9, or the square root of w plus 9 squared is just w plus 9, and then subtract 9 from both sides. 3 equals w. And on number 18, there are 3 variables they want you to solve for. And at first, I looked at this problem and I was very confused by it. I was trying to figure out how I would do it. But then I realized it's the exact same problem as the one from the notes. The very last problem on the notes, this is the exact same problem, just with a z thrown in there. So you're still going to get the exact same answers for x and y. But z is going to be different, and you can use whichever measures you need to solve for z, because you're going to have a lot of measures given to you on this one. But yeah, write out what x and y would be, and then use z as well. And that's all I wanted to discuss on the worksheet for today. Everything else, after I went over those 6 problems, should be okay. Let me know if you have any problems. Come to my office hours if you need help. But I will see you guys tomorrow.